Hello everyone and welcome back to another math video. Today we're going to be looking at how do you simplify radical expressions or square roots, similar to this problem that you see up on the screen. Just a reminder, this is the short version where we're going to go pretty quickly just through the main ideas. If you'd like the full length lesson where we go step by step with a bunch of examples, I will link that in the description below. So the way you read this problem, this says the square root of 16. The square root of 16. Okay, and it's the square root because there's an invisible 2 here in this corner. We don't write the 2, but if you don't see a number written there, it's understood to be a 2. And if you know about exponents, right, that's square. So this is the square root of 16. And we call this sort of check mark symbol, that's a radical. Okay, that's a radical symbol. And what it asks me, this problem is asking me, what number times itself 2 times will give me 16? I'm going to say that sentence one more time. What number times itself 2 times will give me 16? So you could start listing numbers, right? 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. And there's the magic number, okay? And so the answer to this problem is just 4. A regular 4, nothing else added. And what we need to talk about is these numbers over here. 16, 9, 4, 1. These are a special kind of number called perfect squares. And I'm going to list a bunch more here right now. Bam. Okay, here's a bunch of perfect squares. I don't think you'll need anything bigger than this. These numbers would be good to have either sort of mentally in your brain or written down somewhere, but these numbers, we're going to use them in the following problems. All right, what happens, here's our problem, square root of 72. What happens if this number under the radical is not a perfect square, right? 72 is not on that list that we just wrote, okay? So what we have to do is we need to make a factor table for 72. And here's my favorite way to do a factor table. I go 1, 2, 3, 4, 5, 6. We'll just stop there for now. And we say 72 divided by 1 is 72. 72 divided by 2 is 36. 72 divided by 3 is 24. 72 divided by 4 is 18. 72 divided by 5 is a decimal, don't use it. 72 divided by 6 is 12. 7 is a decimal. 8 and 9. And then you can stop because 9 is already on the list here, so we're done. These are all the factors. And now you look at these numbers on your list here that you just wrote, and you ask which one of those numbers is a perfect square, which one of them is on the list that we wrote on this page here. And the answer to that is I see 36 and I see 9, right? These are both on the list. These are both perfect squares. So you can choose either one. However, one is shorter than the other. Let's do the short way first, and then I'll show you the long way just so you know it. All right? It is always better to choose the biggest perfect square. So in this case, the bigger perfect square is 36. So the way you do this is you split the square root of 72 into the square root of 2 times the square root of 36, right? Here's the pair of numbers, 2 and 36. This is multiplied. And then we know that the square root of 36 is just a 6, okay? Square root of 2 stays the square root of 2, can't break that down. And now to write your final answer, you normally write just the regular number on the left side of the radical. So your final answer is 6 square root of 2. And this is the final answer. Now, let's look at what happens if you had chosen the 9 instead. It has an extra step. You can still do it, but let's look at what happens here. Okay, so if you had split this into square root of 8 times square root of 9, 9 becomes the 3, but then the square root of 8 can be split because 8 has perfect squares, right? So 1 and 8, 2 and 4, 3 doesn't work, 4 is on the list. All right, but 4 is a perfect square. So this can be split into 2 and the square root of 4. And then this becomes 2. This is still 3. This is the square root of 2. And now you just multiply your regular numbers together and put them at the front. So you get 6 square root of 2. Final answer, right? You get the same answer. It has some extra steps, though. So that's why it's always better to choose the bigger perfect square. All right, last type of problem. What happens if there's a number already on the outside? Well, still make your factor table for the number under the radical, under the square root. So 1 and 28, 2 and 14, 3 is a decimal, 4 and 7, 5 and 6 are decimals, 7 is already on the list. And then you look for the biggest perfect square, that would be the 4. So bring down your 6, remember this is times, split the 28 into the square root of 4 times the square root of 7. We got that from the table. And then we know the square root of 4 is 2, square root of 7 is still the square root of 7, and the 6 just stays the 6. Now we multiply our regular numbers. 6 times 2 is 12, square root of 7, and this is our final answer. Short way of saying that is the number, the perfect square is just going to get multiplied, right? This perfect square right here just gets multiplied by the number on the outside. All right, here's our cool clock for today, which means that it is time for you to practice what you just learned. Go ahead and pause the video and try these 2 problems on your own. And when you're ready, you can unpause and we'll check your answers. Okay, now that you've had time to work these problems, let's check your solutions. Okay, for the first problem, you should have gotten 35 square root of 3. Here's the work. Sort of ran out of room on my table, but all the way down, we're just sort of getting decimals up until 15. Okay, and for the second problem, here is the work and final answer. Should have gotten 56 times the square root of 7. All right, that is it for today. I hope you all have a good morning, good afternoon, good evening, and good night.